Hello students, we're continuing with scatter plots. Today we are going to be looking at the relationship that exists and we will be drawing the lines of best fit. So when we have a scatter plot, if a pattern or relationship or trend exists, all three of those words mean the same thing, then the two variables have a correlation. Okay? A correlation will exist between two variables when we can identify a pattern or a relationship or a trend. So fancy words, but you do need to know what the word correlation means. The closer the points are on a scatter plot to forming a straight line, the stronger the correlation. So let's look at some examples here. We're going to describe the correlation. So looking at the first example, years in business and number of clients, if I were to draw a line that matches the way the points are moving, that's what my line would look like. So if I were to describe this line, well, I can see that it's touching a few points and the other points are pretty close to it. So I would describe the correlation between these variables, years and clients, as strong because they're close to forming a straight line, and positive because the line rises to the right. Looking at my second example, monthly video rental. So we saw these graphs yesterday. The points, you can see that they're all random, and so there really isn't a pattern. If I were to draw a line, there is no line. There's no sloping upwards or sloping downwards. The points are just random, so I can't connect. So that means that there is no correlation. You could also say it's weak or very weak correlation. Next example, the lake alkalinity and the mercury content in fish. So if I'm looking at the points that are plotted, if I see how they're moving, well, they're kind of moving in this downward fashion. Okay, they're not very close to forming a straight line, but they do move in the downward fashion, with the exception of this one outlier. Remember that word from yesterday's lesson. So if I were to describe the correlation, I would say it's weak or moderate is a good word to use. And I would definitely say it's negative because the line again falls to the right. Looking at my next example, I've got CO2 concentration in ice samples. Okay, so look at all the points plotted. They're very close to forming a line there. They're very close to this line. They're moving in a downward fashion. So if I describe the correlation here, I'm going to say it's very strong because all the points are very close to the line, and I'm going to say it's negative again because my line slopes down. So how do we draw a line of best fit? Well, a line of best fit again describes the pattern or the relationship or the trend that exists between the two variables. When we draw a line of best fit, we want to follow the pattern with a straight line. Now, we can draw lots of straight lines, right? So the objective here, the goal is to intersect as many points as possible. So I want to touch as many points as possible, but I also want to balance all of my remaining points so that I have approximately equal amount of points on either side of the line. So we use our line to make predictions for values that are not recorded. Recall the words interpolation and extrapolation from previous chapters. We will be doing that again today. So drawing lines of best fit in each of our above scatter plots, that's already been done. You can see I've drawn them in already. Again, my line touches as many points as possible, and I try to balance the points on either side of the line. This one here only touches one if I try to balance the points. If I were to draw the line, see if I can move this. If I were to draw the line down there, it's not a very good line of best fit because all of the points are above it. Yes, it's true it's touching 4 points, but every other point is well above. So not the best choice there. So when I move it up here, you can see that I've pretty much balanced my points above and below. So that's a much better line of best fit. Okay, in my first examples here, this one here, strong positive, I would like to try to touch as many, I can put it there, right, but I'm not touching any points at all. So as I move it, oh look, I'm touching points and I'm pretty much balancing the number of points above and below. Okay, so that would be my ideal position for my line of best fit. And for this example here, as we already mentioned, there is no correlation, so there is no line of best fit. Sometimes you'll see a horizontal line drawn, but not necessary. There is no line that you can draw there. Okay, moving on to our next example here. I'm providing you with a scatter plot. I want you to draw a line of best fit. So again, When I draw my line, I'm going to make sure that I touch as many points as possible and that I balance the number of points above and below. So there's my line of best fit. Something I want to point out, students always want to try and make the line of best fit start at the origin. It does not. Okay, sometimes it does, but it doesn't have to. So if I were to draw a line starting from 0, 0, moving upward, that would be wrong. I would not give you full marks for that line of best fit. Okay, so not every line starts at the origin. Please make a note of that. So there I've drawn my line of best fit. Next, describe the correlation between the weight and the tail length. Well, we can see that the line has a positive slope, which means that the heavier the fish, the longer the tail. As X increases, so does Y. If I'm asking you to describe the correlation, looking at that line of best fit, I'm going to say it's positive because it slopes upward, and it's strong because the points are very close to the line. C, estimate the tail length of a perch that weighs 20 grams. So if we go back to the graph, 20 grams. Here's 20 grams. So I'm going to draw a vertical line. I'm going to make this line touch my line of best fit, and I'm going to read across horizontally, and it looks like it's about 2. So there will be a little bit of flexibility here because your lines will not all be identical. So there will be a little bit of a range, of an allowance when you answer these questions. Okay. So you can see here I've written down anywhere between 1.8 and 2.2 would be an acceptable answer. D, estimate the weight of a perch that has a tail length of 3.3 centimeters. So this time I'm looking at tail length has to be 3.3. I start with a horizontal line, move across to my line of best fit. I do not pick one of the points that are plotted. I go to my line of best fit and read down, and I approximate that value, and I have a range as well, and you can see I'll accept anything in between 95 and 110 centimeters. Example 2, again, provided with a scatter plot, I want you to draw the line of best fit. So if you were to draw your line so that it looked like that, no problem, I'd give you full marks, okay? If you draw your line so that it looks like this, no problem, I'd give you, well, I actually would prefer if you kind of moved it down a bit, but I would still give you full marks because they're your touching points, right? You're touching points and you're balancing above and below. So again, there will be flexibility when you draw your lines. So we've drawn our line of best fit. Now, describe the correlation. Well, my line moves upwards, which means it's positive. My points are pretty close to the line, so I can describe it as strong. You could argue that it's moderate and say that the points aren't exactly that close to the line, and that would be fine too. As long as you justify your answer, it's fine. If you were to call this weak, I would not give you marks, but I would accept strong or positive. Either one of those are fine. I wouldn't say it's very strong, okay? So if we're describing, that's how we describe the correlation. And then if I describe what's happening with my variables here, as temperature increases, the heart rate also increases. Estimate the temperature when heart rate is 72 beats per minute. So go across to 72 beats per minute, read across. I don't pick the point, I pick the line, the point on the line, okay? So on the line, looks like we have about 97.1 or 2. Okay. D, estimate the heart rate when temperature is 98.7 degrees. So go across 98. Oh, look, my graph ends at 98.5. So now we're going to use extrapolation. Remember that? I extend my graph. So 98.5, 0.6, 0.7 looks like it's approximately there. I draw my line a bit longer, my line of best fit, read up and across, and it looks like when we hit the line there that it matches with a heartbeat or heart rate of approximately 82.4. Looks like it's somewhere around there. Okay. So for homework, pages 337, numbers 1 to 6. Let me know if you have any problems. Thanks, guys. Have a good day.